Today we're going to look at some Pythagoras Theorem worded questions. A ship sails 15 kilometers due east and then 20 kilometers due north. How far is the ship from its starting point? The best way to do this is to draw a diagram. So here is our starting point. The sail travels due east. Let that be the direction for east. That's 15 kilometers. And then it travels due north 20 kilometers. And there's 20 kilometers. And notice that that's a right angle. And so the ship is now there. And we've been asked to find that distance, the shortest distance to its starting point. So this is a Pythagoras question, and we've been asked to find this length. Now I always like to write by Pythag, and then I always like to write the formula: a squared plus b squared is equal to c squared. In this case, let this one be a and this one be b. So it is 15 squared add 20 squared, and that equals c squared. 15 squared is 225, 20 squared is 400, and that equals c squared. 625 is equal to c squared, and if we take the square root of both sides, so c is the square root of 625, and that gives us 25. So to answer the question, the ship is 25 kilometers away from its starting point. Now, just as a little note, if you notice, this is basically the 3, 4, 5 right triangle. This is just 5 times bigger. That's 5 times bigger, and we got 25 for that, which is 5 times bigger than the 5. So 3, 4, 5 is a Pythagorean triple, and any multiples of that, i.e. in this case 15, 20 and 25. A 3-meter long ladder is leaned against a wall. The foot of the ladder is 1 meter from the base of the wall. How far up the wall is the top of the ladder? Again, the only way to do this is to draw a diagram. Okay, so here's the wall, and here is the ladder. The wall and the horizontal ground make an angle of 90 degrees. We're told that the ladder is 3 meters. And we're told that the ladder is 1 meter from the base of the wall and the floor. Okay, this is a Pythagoras question because we have a right angled triangle. So I'm going to say by Pythagoras, and I'm going to write down what Pythagoras' theorem is. A squared plus b squared is equal to c squared. In this case, this is a, the height the ladder goes at the wall is b, and this is c. So 1 squared plus b squared is equal to 3 squared. 1 plus b squared is equal to 9, so b squared is equal to 9 minus 1, so b squared is 8. Coming up to here, that means b is the square root of 8. Now the chances are we would be asked to write that to 3 significant figures, so I'm just going to find the square root of 8, and the square root of 8 to 3 significant figures is 2.8. Let me just write what I see on my calculator, so on, and that is to 3 significant figures. As a third, so b is equal to the square root of 8 is written in third form in the sense that there's a square root. We could possibly be asked to write that in a simplified third form, and if you notice 4 times 2 is 8, and the reason I did it like that is because the square root of 4 is 2. So if we'd been asked to write it in third form, we would write it like that. A football field is rectangular and has dimensions 90 meters by 55 meters. How far is it from one corner flag to the other on the diagonal? Okay, I'm going to draw a football field, which is just a rectangle. It's 90 meters by 55 meters. And we're being asked to find the length of the diagonal from one corner flag to the other. Okay, this is a Pythagoras question because we have a right angled triangle. This is 55 and this is 90 meters. And we're being asked to find the length of the diagonal. So again, I'm going to tell people what I'm doing. I'm using Pythagoras. I'm going to write down the formula. A squared plus b squared is equal to c squared. In this case, a is 90, b is 55. So it's going to be 90 squared plus 55 squared. And that gives us c squared. So I'm going to go to my calculator. 90 squared plus 55 squared. And that gives us, so c squared is equal to 11125, 11,125. I'm going to take the square root of that now. So take the square root of that. And that gives us 105.4751155, all the numbers in the calculator. And if that was to three significant figures, that would be 105 meters.